Hello, everyone. Welcome to lecture 20. So in today's lecture, we will learn linear equations in three variables. We will see what this type of equations look like and how to solve such kind of equations. So before we learn the linear equations in two variables, and we've seen the solution to linear equation in two variables gives us a straight line. So if we solve an equation of two variables, linear equation of two variables, then the solution would give us a straight line, right? So how about if we have an equation or a linear equation in three variables? And in this case, the solution set of this, or all the solutions, if we combine them, they will give us a plane like this one. Okay, for example, if we consider this example, then the solution to this one, it will give us a plane something like this. Okay, and if we have another equation, another linear equation in three variables like this one, then of course the shape will be different, but it will be a plane. So when we say a linear equation in three variables, we have the variables x, y, and z. Now, this coordinate plane now, it has three dimensions. This vertical, instead of y, now we call it z. This to the right, and of course to the left. This horizontal is y, and here we have the x axis. Okay, so this will be the plane for such kind of equations. And if we plot the points on this kind of plane, then we will have this kind of shape. So this shaded area will be the solution to this linear equation in three variables. Now the next question is, well, let's say we have a system of linear equations in three variables like this one. Because last time we learned how to solve system of linear equations in two variables. If I have, for example, 2x plus y equals to 0, 3x plus 5y equals to 10, for example, then we know how to solve such kind of equations. And we learned two methods. One is the substitution method, and another is the addition method, and or we call it elimination method. Okay, so this is solving system of linear equations in two variables. But the question here is, how about if we have a system of linear equations in three variables? Now, to answer this question, we will see this example, and we will try to learn how, I'll try to explain how we can solve such kind of equations or system of linear equations in three variables. And then we will see another example, of course. So if we have system of linear equations, first let's name this equations. So the first one we call it A, the second one we will call it B, and the third one we will call it C. So this represents the first equation, B represents the second equation, and C represents the third equation. Then what we do is, well, of course, first we have to make sure that the equations are written in a standard form, which means we have the x variable, the y variable, the z variable, and then the constant here on the right side. And all of them, they are in that format. Then the next is we choose two variables, two equations from this three. Let's say we pick A and B. And from those two, we try to eliminate one of the variables, one of the three variables. So for example, I will pick A and B. A is 2x minus y plus 5z equals to -7, and B is this is B. So which one is easier? It's up to you. You don't have to. There is no rule which variable to eliminate. But for me, for example, I will choose this because it looks easier to multiply it. Here we have the coefficient 2, and here we have the coefficient 1. So I will multiply the second equation by -2 so that the x variable on these two equations will have opposite coefficient. Therefore, here we multiply this by -2, and we get the first one is as it is, and the second one will be -2x plus 8, should be minus 8y plus 4z equals to -2. Now we add this. This is just the addition, the elimination method or the addition method. If we add this, this will be 0, and if we add this, we get -9y plus 9z equals to -9, right? Yes. Okay. And now let's call this equation D. Okay, we are naming each of these new variables. So if you notice here, this equation, it has only two variables now. We get rid of the third one. And again, we go back to this original equation, system of linear equations, and we pick different pairs now. Either earlier we picked A and B. Now we can pick A, C, or B, C. Okay. So again, let's pick B and C, because that one again looks easier. B and C. So B is x plus 4y minus 2z equals to 1, and we have 2x plus 2y plus z equals to -7. Okay, so again, now here, since we eliminated x, the x variable, we should do the same thing here. We need to eliminate the same variable. So I will eliminate x from these equations. So to do so, I will multiply the first equation by -2 again, and we get -2x minus 8y plus 4z equals to -2, and this is as it is. Okay, and now we add this, and this will be 0, and this will be -6y. This will be 5z, and this is -9. And let's call this E. Okay. Now, if we look at D and E, these two are equations of two variables. Therefore, and if we notice, both the variables are the same. So I will write them here. Equation D and equation E. So D is -9y plus 9z, -9, -6y plus 5z equals to -9. Okay, let me see. Let me double check here. Okay, if we multiply this, we get -2x, -8y. Okay. Okay. All right. So here we have system of linear equations in two variables, right? So we will use those techniques, either the substitution or the elimination method or the addition method. But again, I will use the addition method. So let's multiply the first equation by let's say, for example, I wanted to eliminate this z. So I will multiply the first equation by -5, right? So we get 45y minus 45z equals to 45. And then the second equation, we multiply it by +9. And then we get, this would be -54. Oops. 54y plus 45z equals to 45. Oops, this has to be negative, yeah. So now if I add this, if we add this, we get 0, 0. No, this one is, what do we get here? 9, -9y equals to, and we have 0, so y is 0. Okay, so we got y, we solved for y, so y is 0. And then I will go back to this one, and I will solve for z. So pick one of them, pick one of these equations, one of these, either D or E. I will choose, it doesn't matter. I'll pick equation D. So we have -9 times 0 plus 9z equals to -9. Now this is 0, right? So 9z is -9. This means z is -1. Okay. And now we found the values of the two variables, and we are left with one more. And now we go back to the original equations and we pick one of these ones. Okay, pick one of them and then solve for the remaining equation, variable, sorry. So here I have this. And now since the values of x and z, y and z are known, then 2x minus y is 0 plus 5z is -1 equals -7. So 2x minus 5 is -7, and x will be, if we take this one to the other side, it will be -2, so x is -1. Okay, therefore the solution is the solution to this system of linear equations is -1. We start with x, 0, and -1. Okay, so this is the solution to this system of linear equations. And well, the step is, it's a bit longer, but it's not that different from that of the system of linear equations in two variables. Okay, let's do one more example. Well, we will have another example, of course, not only this one, but let's have a look at this one again. So again, we will follow the same steps. So again, let's rename this, name this. So we have A, B, and C, and then let's pick A and B. And B, A is x plus y plus 4z equals to -1, and B is 3x plus y minus 4z equals to 3. And this is B. And what do we do next? Well, again, we need to eliminate one of them. we have to choose which one to eliminate. So as you can see, eliminating this y is easy because we don't have to multiply it by a number, just by a big number. We just multiply it by -1, right? One of them. So that's much more easier. So I will pick, I will eliminate y. So I will multiply this by -1, multiply by -1, and we get -x minus y minus 4z equals to +1, and the other one is as it is. And then we add these two equations, and here we get 2x, this is 0, and this is -8z equals to 4. And let's call this one d. And again, we pick maybe B and C, doesn't matter. So we pick B and C. Let's rewrite them. 3x plus y minus 4z equals to 3. And C is -4x minus y plus 8z equals to -2. Now here, we don't need to multiply it, of course, because the y variables in these two equations, they have opposite signs. We have +1 and -1. So if we add them, they will cancel out. Therefore, I will just add this, and we get -x. This is 0, and this is plus 4z equals to +1. Okay. And what do we get? So here we have, again, let's rename this one. This is equation E. Now, if I write equations D and E together, what do we get? Equation D is 2x minus 8z equals to 4. And this E is -x plus 4z equals to 1. And in order to cancel out one of these variables, I will multiply the second one by 2, and we get, the first one will be the same, and the second one will be -2x plus 8z equals to 2. Now what do we get? So from here, if we add this two, we get this is 0 and this is 0. So we have 0 equals to 6. And what does this say? What does this tell us? Well, we learned from the system of linear equations in two variables that if we end up with such things, even though they are not the same, the two numbers, but if we end up like one number is equals to a different number, then that means this system of linear equations doesn't have solution. Okay, so this system of linear equations doesn't have solution. And what do we call such kind of solutions, such kind of system of linear equation? Inconsistent this should see inconsistent. Okay, so such kind of system of linear equations are called inconsistent system, which means they don't have solution together. Okay, they don't intersect. And one more example. Again, we consider this example. Now here it's a bit different, and the reason why it's different is because the first equation, it doesn't have the x variable. There is no x here. From the second variable, y is missing. The third variable, it has all three of them. So first, let me rewrite them. let me call them first. Here, A, B, and C. So let's rewrite this. So I will leave space for the X. I will have 5y plus z equals to 0. And then we have negative x plus, here we don't have anything, plus 4z equals to 0. This is just 0, just you can put placeholder right here. Okay, and then here we have 5x plus 5y plus 5z equals to 0. Now, since this one doesn't have any x, and this one has x but not y, and this one has 3 of them, what we could do is we could eliminate x from this, and then we can use the first one and the second one to solve for as a system of linear equations into variables. And what I mean by this is, for example, if we take the first, the second and third, let's say we take B and C, and the equations are negative x plus 0y plus 4z equals to 0. This is not necessary to write it, but for now, since just to show you that we can solve this kind of equations, I am putting this placeholder. Otherwise, you are not, it's not a must to put it there. Okay. 5z equals to 0. Now, in order to eliminate x, what do we need to do? We need to multiply one of them by negative 1. Okay, one of either the first equation or the second equation, and it doesn't matter which one you pick. So let's multiply this by negative 1. And if we multiply this by negative 1, what do we get? We get x plus 0y plus minus 4z equals to 0. And this will be as it is, equals to 0. Now, if we add this, what do we get? This is 0. This is 5y. This is z. And here we have 0. And now I will rename this one. I will name this one. Let's call this D. So let's pick A and D. So because the reason why I'm doing that is because equation A doesn't have the variable x, and equation D the same, doesn't have the variable x. So they both have the same variables y and z. Now I can use the system, the techniques that we learned to solve system of linear equations into variables. So let me write this one. Okay, and here these two, they are opposite sign. They are the same. Both of them, they are exactly the same. So let's multiply just to for illustration. Let me multiply this by negative 1. If we do so, what do we get? We get negative 5y minus z equals to 0, and 5y plus z equals to 0. And if we add this, we get 0 equals to 0. And what does this mean? This is the same idea with the system of linear equations in two variables. So if we end up with such kind of thing, then the system is consistent, and the solution set, well, there are infinitely many solutions. Okay, there are infinitely many solutions to this system, which means basically they intersect everywhere. Okay. Yeah. So now, if we have such kind of system which is consistent, and if the solution, if there are infinitely many solutions, then we can write the solution as a function of one of the variables. For example, the first one we can solve for because as you can see, all the equations they have the variable z. So I will write x, y, and z. X, y as a function of z. So from the first one, from here, if you solve for y, we get. Let me put it down here. So we have 5y plus z equals to 0. Then solving for y, we get 5y equals to negative z, and then y equals to negative 1 over 5 z. And from the second equation, negative x plus 4z, negative x plus 4z equals to 0. And solving for x, negative x equals to negative 4z. And multiplying both sides by negative 1, we get x equals to 4z. Now the solution to this system can be written as a function of z. So I can write this as okay, let me parentheses, x is 4z. Let me use color. For z instead of x, y is negative 1 over 5 z. Z is z by itself. Okay, so this is the order pair such that we put this bar, or sometimes we can put this semicolon, such that z is any real number. So basically what we are saying here is, if you pick a number, any real number, and if you solve each of this, for example, if I pick, let's say z is negative 2, if z is negative 2, then this becomes negative 8, this becomes 2 over 5, and that becomes negative 2 itself. So this is solution to this system, that means. Okay, we can even try it. This should be a solution to the system. For example, let me copy the so I'll bring it down here. So to check whether this is a solution or not, for this one, y is 2 over 5, so 2 over 5 plus z is negative 2 equals to 0. So here we have 2 minus 2 is 0. So this is true. And for the second equation, x is negative 8, so negative times negative 8 plus 4 times z is negative 2 equals to 0. So this is positive 8. This is negative 8. And this is true again. And for the third one, we have negative 8, 2 over 5 plus 5 negative 2 equals to 0. Negative 8, oh, this has to be positive. This is positive 8 plus this is 2 minus this is 10. So we have 10 minus 10 equals to 0. Again, that's true. So we can write the solution to the system of linear equations, because now we know from here we know it has infinitely many solutions, because we end up with such kind of equality, and this equality is true, and which means the system has infinitely many solutions. If this is not true, if you end up with something like this, then the system is inconsistent and there is no solution to the system. And now So if we know that there are infinitely many solutions, we can write the solution as a function of one of the variables. It doesn't have to be z, it could be x, it could be y, but in this case I just chose z. So now you pick any value for z and you solve for x, you find the values of x and y, okay? And then you will have the three pair of numbers, and that will be the solution to the system. And just like what we did in this example, so we picked a value for z, which is -2, and then we solve for x and for y, and then we checked if this is a solution, and yes, it's a solution to the system. Okay. All right. So this is all for this lecture, and see you in the next lecture.